Hello everyone. Today in this video, we are going to study the isotopes, the concept of isotopes and the applications. We'll discuss some of the applications of isotopes. In the last video series, we have seen the atomic structure and the concept of protons, neutrons and electrons, their number, charge, etc. And therein we have given the new concept of isotopes, which is depending on the number of protons, neutrons. Let's get started with the isotopes. So before we get started, let me tell you the isotopes. The word is made up of two parts, two words, iso and topos, wherein iso means the same and the topos means place. So why it is called same and why it is called place, and what is the relationship of the isotopes with the protons and neutrons number? Yeah, let's see in this video. So before we going dive into straight to the topic, we need a quick revision of this atomic structure. Atom consists of two parts, nuclear part and the non-nuclear part. We all know that in the nucleus, the two subatomic particles named protons and neutrons present, while in non-nuclear part, that is other than nucleus, we have electrons. Electrons are negative in charge and they revolve around the nucleus. In the nucleus, the protons are positively charged, neutrons are neutral in charge. Next, we have seen that the number of protons are always equal to the number of electrons, okay? And these two numbers are known as the atomic number, okay? Number of protons are always equal to the number of electrons, and these numbers are known as the atomic number. Protons having positive charge, electrons having negative charge, they both are same, equal, and they cancel each other, and hence the atom becomes electrically neutral. What is the role of neutron over here in the atomic structure? If the neutrons are having neutral charge, why even they are here? Number of protons plus number of neutrons gives us the new terminology, that is the mass number, that we have discussed in the earlier videos. If you have not seen, please go and watch this video for the better understanding. So neutrons, are they only contributing for the mass number? No. Basically, in the nucleus, we all know that there are protons and electrons. Protons and neutrons. Electrons moves around the nucleus. Okay, electrons are having negative charge. They maintain a particular distance. They have different orbits that we have seen in detail in the last video. Protons are there in the nucleus and they are very close by each other. So as they are having positive in charge, they try to repel each other. Okay, protons are having positive in charge and they try to repel each other. So neutron part will come into picture. Neutrons try to hold them together, right, in the nucleus. So that is the role of neutron over here. And yeah, we'll see what is that next. So what is isotope? Isotope means the same atomic number with a different mass number. Those are known as the isotope. So there, I hope we have studied the periodic table, into we have seen the all the elements along with the atomic number, right? So what is that atomic number? Atomic number means the number of protons, okay? So the atomic number, that is number of proton, is same, but some elements are having different mass number. So different mass number means they are differ in number of neutrons, okay? Because mass number is nothing but number of protons plus number of neutrons. So the same atom or the same element having the same atomic number but the different mass number. So these are known as the isotopes. The number of neutrons gives us the new concept that's called isotopes. So because of this imbalance in between the number of protons and neutrons, nuclei are unstable. Nucleus is becoming unstable. Unstable, what it happens then? It becomes radioactive, or in case it is not radioactive. So yeah, isotopes are categorized into radioactive and non-radioactive, and all the isotopes are having the different physical and chemical properties. That is very interesting. That's why we are studying this isotope, because even if they belong to the same element, and they are having the same atomic number, but because of their different mass numbers, they have generated the different kind of isotopes, and that leads us giving the different physical and chemical properties. They behave differently, and some isotopes emit rays alpha, beta, gamma. So these are known as the radioactive, and some isotopes are not emitting any of the rays. So these are called as a non-radioactive. For your sake of understanding, I have given here one example of carbon. We all know that the carbon is having atomic number 6. What I have written here is C12, C13 and C14. So these are the three isotopes of carbon. So what is that 12, 13 and 14? Yes, you are right. So these are the mass number. As the carbon is having 6 number of protons, here 12 number is representing the mass of carbon. So yeah, for your better understanding, I have taken all the information in a tabular form. So here the first column is representing the isotopes. I have written here the Ce, that is the symbol of carbon, and the superscript is 12, here 13 and here 14. So mass number of this isotope is 12, mass number is here 13 and mass number of this is 14. Now I know that the atomic number of carbon is 6, means the proton numbers of all these elements will remain same. Always remember, the number of protons are not going to change in the isotopes. What is going to change is the number of neutrons. And how to get the number of neutrons? Mass number minus number of protons will gives us the number of neutrons. So yeah, 12 minus 6 is 6 number of neutrons, 13 minus 6 is 7 and 14 minus 6 is 8. So yeah, for these isotopes we have these number of neutrons. Now we'll study one by one the applications of isotopes. The first one we'll discuss is the uranium-235. So uranium-235, it means that we have the element called the uranium and who's having the mass number is 235. Atomic number is 92, as it has 92 number of protons and 143 neutrons. So as you can see, 143 plus 92 is 235. Now what is the significance of this uranium-235 and why we are studying? It's a very important element. It's a very important isotope, and detailed information about this in a nuclear reactor we're going to study in the next video. For now, I have taken the short introduction about this in the applications of isotopes. So basically, in a nuclear fission, the process is like the atom is getting split into two smaller parts. Okay, that process is sometimes controlled and the process is sometimes uncontrolled. When it is controlled, we can generate the electricity in like a nuclear power plant, and when it is uncontrolled, we can create like it created in the explosion and nuclear weapons. Okay, because when the atom is getting splitted, this process is very random and spontaneous and it releases a lot of amount of energy. So that is nuclear fission, wherein uranium-235 isotopes is being used. So yeah, we'll see the next application, that is cobalt-60. There are lot many applications in various fields. So I have discussed here some of them. This cobalt-60 isotope is used for the medical treatment. And how it is used for medical treatment? See, every line I have mentioned here, the number 60, and you get it here, right? 27 plus 33, that is 60. So basically, this is the radioactive isotope. It is emitting high energy gamma rays, okay, because the imbalance in the neutrons and protons, the nucleus become unstable and it is constantly emitting some rays outside of it. Okay, so these gamma rays can be used to kill the cancer cells, okay, the present in the human body. It can be used for that. Also, it can be used to sterilize the medical equipment to reduce the spread of the infection. So for all these things, the cobalt-60 isotope is used. The third one, I'm here discussing the iodine-131. Again, it is used one of the treatment for the medicine, goiter, the disease of thyroid gland. Yeah, 131 means 53 plus 78. Again, it is radioactive isotope. And how it is taken? You can even inject this into a body and it is very safe. Okay, it is taken orally as a capsule or a liquid. What happens when it is taken inside the body? It absorbed by the blood will go to the thyroid gland will absorb it, and yes, the iodine 131 will radiate some radiation, will emit some radiation, and this radiation used to kill these thyroid cells and then the symptoms getting relieved. Okay, so this is how this can be used. So there are tremendous applications of these isotopes. One of them we discussed, like sodium 24 is used for leak detection in the underground pipe. So yeah, the 24 is the mass number, 11 number of protons and 13 number of neutrons. What is the atomic number of sodium? Yeah, it's 11. It's not going to change. So yeah, what is the procedure? So basically sodium 24 is getting dissolved in the water, right? Small amount of sodium 24 is taken and it is dissolved in the water. Then that water is injected into the pipe. Okay, whose checking is been done, and then one detector is used, radiation detector is used. So wherever there is a sodium 24, this radiation detector will detect it and we can easily check the crack where it is, the leaking is going out. So yeah. Okay, the second last application we are discussing here is again the preservation from the microbes. cobalt 60 and cesium 137. Even if the cobalt 60 is very dangerous, it is used to kill the bacteria and microorganisms present in the food. Basically, the food which is to be preserved and is placed on the conveyor belt, and the high res high radiation emitting out from these isotopes be bombarded on the food whose needs to be preserved. So these rays are going to kill the bacteria present inside of that, bacteria and microorganisms. So what happens because of that, the shelf life of the food is getting increased. Okay, by doing this we are not changing or its taste, texture or color, anything is not going to change. This is very safe method and it's given even permission from the WHO, World Health Organization. So yeah, after radiation, food becomes completely safe. It's just used to kill the bacteria.